Welcome, fellow educators. If you're anything like me, you pour absolutely everything into your subject. But let's be totally honest here. The landscape of higher education is just shifting way faster than our syllabi can keep up. So in this explainer, we're going to dive into a framework that helps us transition from giving passive lectures to building dynamic, active, problem-based learning ecosystems. It's a real game changer. Let's just kick things off with a pretty blunt question. Are your lectures preparing students to pass an exam, or are they preparing them to actually survive out there in the real world? Seriously, take a second to think about that. How often do we stand at the front of a hall, delivering this brilliantly crafted material, only to look out at a literal sea of blank passive faces? You know the look. And it's not that they don't care. It's just that the traditional format basically conditions them to be passive receivers. We're teaching them to memorize, regurgitate, and then immediately forget it all. But as we all know, the real world doesn't exactly hand out multiple-choice tests.
So, let's get right into Section 1, the crisis of traditional teaching. When you really look at it, we're operating between two completely different realities. On one hand, we've got this traditional deficit. This is what happens when we just overload students with pure memorization. It leaves a massive competency gap because it totally fails to develop their critical thinking skills for a really volatile world. But then, on the flip side, we have the problem-based learning imperative, or PBL. This is where the magic happens. The focus completely shifts from what you are teaching to how the student is learning. We use complex, messy problem situations because, quite frankly, they are demonstrably more effective than just memorizing facts.
Which brings us to Section 2, from lecturer to architect.
Think about the traditional lecturer. They're the single primary source of answers, right? Just delivering one-way information. But what we really need to become is the active facilitator, an ecosystem architect. As an architect, you're filtering the noise. You're reducing or increasing external stimuli to actually guide the student's inquiry. You provide the scaffolding so they can solve the problem themselves rather than just handing them the answer key. You are engineering situations where they have to immediately activate new knowledge, test it out, and hit up against its real-world limitations. You aren't just talking at them anymore. You're building the very world they learn in.
This whole evolution leads to a complete classroom role reversal. It's a dual shift. For the students, they move from being passive receivers to active investigators, synthesizing data and taking on formal roles. And for you, you move from being the sage on the stage to the guide on the side. You actually step back. You become a facilitator who mostly intervenes just to manage the process and keep group dynamics in check. You keep control by asking really probing questions that force them to dig deeper. And honestly, once you get the hang of it, it is incredibly liberating.
All right, moving on to Section 3, key benefits of problem-based learning.
So, what's the ultimate payoff for all this? In a word, real-world readiness. This framework unlocks advanced analytical reasoning and critical thinking in a way that a standard lecture literally never could. It drives highly effective multidisciplinary collaboration. And because they're tackling authentic, messy problems, it generates this deep, intrinsic motivation. They actually start to care about the outcome. Ultimately, it builds the strategic agility they're going to need for complex professional challenges. We're talking about transforming higher ed from a static catalog of facts into an actual engine of future action.
Let's look at the data in Section 4, evidence, successes, and challenges.
Check this out, a solid 10% increase. That stat comes straight from the Biomedical Science Frontier Study, which tested out flipped learning and case study-focused PBL. Now, full disclosure, students actually hesitated at first. Active learning requires way more brain power from them, so pushback is totally normal. But once they actually engaged with the method, attendance rates soared 10% higher than in the traditional lecture units. Turns out, students actually show up when they know their presence is crucial to solving the problem.
And the engagement metrics get even crazier when you look at digital resilience. A recent Warsaw University of Technology case study looked at remote learning models. Passive e-learning models averaged about 45 loggings per half semester. But the active ePBL teams, those students logged in up to 267 times. That is a staggering jump. They weren't just clicking around, they were actively co-creating documents and driving peer discussions. It completely shatters the limits of what we thought was possible with remote engagement.
Okay, but let's be completely transparent here and address the elephant in the room, group work. The tension of collaboration is real. The rewards are absolutely massive, with over 75% of students saying it significantly develops their teamwork. But almost 79% also reported extreme frustration with unequal workloads and free riders. We've all seen it happen, right? This is exactly why your new role as an active facilitator is so absolutely crucial. You cannot just leave them to it. Structured assessment and your direct intervention are required to manage that ecosystem and mitigate the friction.
So how do we actually do this? Section 5, Tools for Immediate Implementation.
I know what you're thinking. You're wondering how to do this without completely losing your mind or rewriting your entire syllabus tonight. Don't worry, you don't have to overhaul everything overnight. Look at it as an implementation spectrum. Start small at level 1, the single module. Just replace one traditional lecture sequence with a PBL module. It's super low risk and introduces the students to the method safely. Down the line, maybe you move to level 2, a hybrid semester, and eventually your institution might reach level 3, a fully progressive curriculum. But for now, just start at level 1.
Now, to solve that massive 79% frustration rate with free writers we just talked about, here are a couple of ready-made tools you can use tomorrow. Force some structure onto these groups by assigning official, formal roles. Make someone the chair. It's their literal job to structure the meeting and force equal contribution from the quiet folks. Make someone else the scribe, responsible for synthesizing the data on a shared document. By formally assigning these roles, you create instant accountability, which drastically cuts down on students trying to hide in the background.
Finally, as you start building out these modules, use this 4-step cognitive engine to guide your students. First, analyze. Force them into systems thinking so they truly understand the complex situation. Second, imagine. Trigger their ability to envision multiple different futures. Third, define. Make them figure out the normative values and goals. And lastly, act. Have them actually develop the strategic competence to design real transformation strategies. It's a brilliant progression that moves your class smoothly from just analyzing a system to actually acting on it.
To wrap up this explainer, I want to leave you with this really powerful thought. Problem-based learning is not a method of teaching. It is an environment for learning. Your role as a modern educator is fundamentally shifting. You are an architect now. This transition isn't just some passing academic trend. It's how we build graduates who are equipped not just to memorize the world, but to actually go out and solve it. So, my challenge to you is simply this. How are you going to architect the environment in your very next class? Thanks for joining me and good luck building.